Everyone, today's our video is about inheritance polymorphism. But first we will look what is inheritance. This provides a way to create new class from an existing class. The new class is a specialized version of the existing class. So inheritance is a relation which inherits the attributes and behavior from its parent class. For example, dog is an animal. It means animal is a parent class and dog is the child class. The child class dog inherits the attributes like age and weight from the parent class, which is an animal. You can see the inheritance in this figure. Using inheritance, we can define a new derived or child class based on an existing parent class or superclass. The derived class inherits all the fields and methods of the superclass. It can define additional fields and methods, and it can override existing fields and methods. Inheritance means a parent-child relationship between classes. It allows sharing of the behavior of the parent class into each child class, the code sharing between classes through inheritance. The child class can add new behavior or override existing behavior from parent class. The new class is a specialized version of the existing class. All the data and methods available to the parent class is also appear in the child class with the same names. There is inheritance terms superclass, base class or parent class. It aims to describe the parent in the relationship which shares its functionality. Then we can see class called subclass, derived class, child class. It aims to describe the child in the relationship which accepts functionality from its parent. Then we can see extend, inherit, derive. It becomes a subclass of another class. This is syntax of inheritance. Class widget void paint, then class push button, public widget void paint C++. In C++, the syntax was inheritance is shown, class push button colon public widget. Then in Java we can see the public class push button extends widget. This is how the inheritance is implemented in different languages. In Ada we can say it is like type push button is new widget with. This is the syntax for inheritance. Methods of the base class are still accessible in the derived class using scope resolution in C++, using the super keyword in Java or Smalltalk. So you can see in different languages how inheritance is implemented. Derived class can restrict the visibility of its object class. Derived class can restrict the visibility of base class members in objects of the derived class. Class A public B. All methods have the same visibility in the derived class as in the base class. If the keyword is protected, class A protected B, then public and protected members of the base class become protected in the derived class. The private members remain private. Then class A private B, all members of the base class become private in the derived class. We can look what is class access specifies in C++. Class access specification determines how private, protected and public members of the base class are inherited by the derived class. Public members are visible anywhere the class declaration as in scope. Then private members are visible only inside the class methods. Then protected members are visible inside methods of the class or its descendants. We can see what is encapsulation and inheritance concept. In these modules are there classes, nesting, type extension without inheritance. Module-based languages with the data hiding innovated in 1970 like Clue, Modula and Euclid. In Clue and Euclid, declaration and definition of a module always appear together. The header clearly states which of the module's names are to be exported. If a Euclid module M exports a type T by default, The remainder of the program can do nothing which objects of type T other than passing them to subroutines exported from M. Then encapsulation and inheritance modules. In module 2, programmers have the option of separating the header and the body. Internal modules in which two parts appear together. In an external module, the header appears in one source file and the body in another. There is no way to divide the header into the public and private parts. Everything in it is public. ADA, which allows the header and bodies of the modules to be separated by allowing the header of a package to be divided into public and private parts. A type can be exported opaquely by putting its definition in the private part of the header and simply naming it in the public. Package view is a header, then type D is private. The private means definitions below here are inaccessible to use, says type T is full definition, then end full. Next we look what is classes. Private members of a base class are never visible in a derived class. Protected and public members of a public base class are protected or public respectively in a derived class. Protected and public members of a protected base class are protected members of a derived class. Protected and public members of a private base class are private members of a derived class. We can see inheritance versus access. Is in this class grade. We can see private members, public members, then class test public grade. Private members is there. When test class inherits from grade class using public class access, it looks like this. How the test class inheritance from grade class using public class access. It is shown in this. Here in this we can see in class test also there. In test class inheritance, okay, from grade class using protected class access. It looks like this, how the protected is using. We can see the private, when test class inheritance from grade class using private class access, it looks like this. So visibility rules in other languages. One is EFL. These derived classes can both restrict and increase the visibility. Java, it is similar to C++ with the following exceptions. Base class are always public. Protected members are visible in derived class and in same package. In Python, all class members are public. In Smalltalk, Objective-C, all methods are public, all fields are private. Encapsulation and inheritance classes visibility. EFL is more flexible than C++ in the patterns of visibility, and derived classes in EFL can both restrict and increase the visibility of members of base class. Every method can specify its own export status. The status is none, then the member is effectively private, which is called secret in EFL. If the status is any, then the member is effectively public or generally available in EFL. Java and C# follow C++ in the declaration of public, protected and private members, but do not provide the protected and private tokenacies for base class. The protected keyword has a slight different meaning in Java than it does in C++. A protected member of Java class is visible not only within derived class but also within the entire package in which the class is declared. Then C# defines protected C++ does but provides an additional internal keyword that makes a member visible. Members of C# class are private by default. Then we can see what is inner classes. Inner classes is a class defined within an outer class. Inner is a member of outer. Inner's methods see outer method members. C# and C++ allow access to only the static members of the outer class since these have only using single inheritance. Then Java allows a nested class to access the members of its surrounding classes. So each instance of the inner class must therefore belong to an instance of the outer class. This is how the encapsulation and inheritance inner classes in Java. You can see in this class outer, the class inner, the inner, then outer, it is a constructor. Then it becomes, we can see, encapsulation and inheritance. How inner classes is using in Java. If there are multiple instances of outer, the instance will have a different end and calls to inner dot bar will access the appropriate end. Each instance of the inner must contain a hidden pointer to the instance of outer to which it belongs. Smalltalk, Objective-C, EFL, C++, Java, C#, where all support a module as type approach to abstraction, which a single mechanism provides both encapsulation and inheritance. Several other languages including Modula 3, ADA 95, Oberon, Close, Fortran 273 can be categorized as object-oriented extension to languages in which modules already provide encapsulation. Other than alter the existing module mechanism, these languages provide inheritance and dynamic method binding through a mechanism extending records. Extending without inheritance. When dealing with pre-existing code, if the class 1 wants to extend, many may not permit inheritance. For instance, in Java, it may be labeled final. In C#, it may be sealed. For situations like these, C#3 provides extension methods which give the appearance of extending an existing class. An extension method must be static and must be declared in a static class. Its first parameter must be prefixed with the keyword this. Okay. Then encapsulation and inheritance extension methods in C++. There is no special functionality is available to extension methods. They cannot access private members of the class that they extend nor do the support of dynamic method binding. In next video I will tell about polymorphism. Till then, bye.